graph this function, and the first thought that comes to mind is, what is it? It's a piecewise defined function. So we will have two pieces because it has two pieces, right? And they cannot overlap. I will not graph something like this because this is a piecewise defined function, right? And this was not a function. If I graph something like this, by the vertical line test, it's not a function, right? So my first thought after that is that this is an interval that is negative infinity to 0, and this is an interval that is 0 to infinity. Why do I do this? Because I need to establish the domain. What is the domain of this function? Very good. It is all real numbers. Do we understand why it's all real numbers? Everyone? Okay. Because we have everything from between negative infinity and 0, and we have 0, and we have everything from 0 to infinity. So 0 is the key point. Underneath 0, I will present this symbol. And underneath 0 to the other side, I will present this symbol, and they are touching. Because I don't have a special number in there, right? And two parentheses. So again, this is an overkill, but it keeps me, bless you, it keeps me on track. So this is x squared minus 1, and this is arctangent. So I know how to graph x squared minus 1 using transformations, right? So x squared is this for the entire function, and x squared minus 1 is this. But not this side, because I'm specifically told between negative infinity and 0. So I will plug in negative 1. When I plug in negative 1, what do I get?
0.
Yes, very good. I will plug in 0. What do I get? Negative 1. And the left-hand side is done. Now the right-hand side, when I plug in 0, you should say don't, but I have to. Otherwise, I have to plug in 0.000000001. I cannot miss anything. So when I plug in 0, I get 0. What angle has tangent 0? 0 radians. And then I'm going to put 1 radian. One as a number, I'm sorry, 1 as a number. And I apply arctangent to 1, and I get an angle. What is the angle? Which angle has tangent 1? 5/4. Yes, you can approximate this. Is it definitely less than? You take your calculator, is that's what you want. I'm not going to plot that exactly because I can't anyway. So I divide 3.14.
170.
Right, 0.7, exactly. So this is approximately 0.7. Good, and now I'm ready to graph this function. I can immediately answer the questions on limit as f of x as x approaches 0 from the right. What will you say?
0.
Perfect. So this is 0. Limit as of f of x as x approaches 0 from the left. What would you say? Negative 1. And what would you say from either side? That's it. So let's finish up the graph. So first I start with negative 1, 0, which is this point. Then 0, negative 1, which is this point. I know that this is quadratic. And it's done. I cannot extend to the right. Now for this one, 0, 0 will be an open point. And I know that at 1 is 0.7. But I have to remember something about, very important about arctangent. Arctangent has two horizontal asymptotes, but since I'm only interested in this side, the horizontal asymptote is at pi/2. This is 3.14 divided by 2. So something is wrong here. So 3.14. My calculator has died. Aww. Okay. So this is 0.35, right? Because I'm divided by 4. So 3.14 divided by 4. 0.78 and 3.14, okay, divided by 2. That is 1.57. Okay, very good. That was what I was missing. So this is okay. So so this is approximately 1.57. So if this is 1.57 will be here. So this is the y equals pi over 2, horizontal asymptote, and now I'm done. So this is the graph of the piecewise defined function, and now I'm asked to find the range. Not difficult. To find the range is what? That's it. Very good. Okay. Any questions on this? Okay. From the lowest y value to, that's okay, to the largest y value. Is that better? Please ask any question anytime. Please. Okay. Now I would like to look at this. I want what? What is dq? Difference quotient for this function. 2x plus 1 over x minus 3. 2x plus 1 over x minus 3. Now in this class we have to remember the difference quotient. In the previous class we didn't have to. Can anyone remind us what is the difference quotient? Over h. Very good. So the difference quotient for any function is f of x plus h minus f of x divided by h. What has to happen for any function that I am asked to simplify the difference quotient? Two things have to happen. What is the first one? All terms at the top without h must go away, must cancel out. Some of the terms with h may go away. That's accidental. But it's mandatory that at the top, all terms without h must cancel out. Otherwise, there is an error. What is the second thing that has to happen? This h from the bottom must go away. The simplified form will still have h in it, but not that h. Okay, so let's work on this. I'm coming around to see what you're doing. This is another idea to commit to memory. Whenever I find and simplify the difference quotient of any function, two things must happen. I would commit that to memory. Because otherwise, I mean, if I do remember that, it would be easier for me to find my errors. If the terms don't cancel, something is wrong. If h from the denominator doesn't go away, something is wrong. From what I see, we do have to come early, class early, and form some study groups and practice. That's my first conclusion. How do we do it? Yes, we see. No, please erase this. Okay, let's talk about something here. So please pay attention 1 second, and then you can continue. Just let me just mention something which is very important, and I have to rely on you when something is not clear. I have to rely on you that you will raise your hand and say, this I don't remember, show me. Okay? Because otherwise, if we let questions and mistakes to pile up, then it's going to be hard to revisit everything. Okay. So if you ask me what I see here, I will say this to you. This is what I see. This is what this function is telling me. It's telling me that f of blah equals 2 times blah plus 1 over blah minus 3. So now if I replace blah by whatever you want, like what I want is x plus h. If I replace it by x plus h, I have to replace it everywhere by x plus h. It's not an x and then somewhere plus h. No. So f of the variable is 2 times the variable plus 1 over the variable minus 3. That's the pattern. That's what the function is telling us. Is this clear? If it's not, please raise your hand. I'll come over and help you. It's okay. But it's better to clarify now because in a month it's going to be very difficult. Do we understand this? Yes. Right. Right. So now this piece is your x plus h. This piece is your x plus h. And this piece is your x plus h. It's not f of x plus h. It's f of x plus h. Which becomes 2 parentheses x plus h plus 1 and x plus h minus 3. So f of x plus h will be twice x plus h plus 1 over x plus h minus 3. Is it better?
Yeah.
Because that's what the function is telling me. The function says 2 times the variable plus 1, 2 times the variable plus 1. This is the variable now.
Okay.
Over the variable minus 3. Variable minus 3. Better? So how will I determine f of 3? F of 3 will be 2 times 3 plus 1 over 3 minus 3, correct? How do I do f of 0? F of 0 would be 2 times 0 plus 1 over 0 minus 3. Now how do I determine f of x plus h? 2 times x plus h plus 1 over x plus h minus 3. Exactly how I did with 0, exactly how I did with 3. Better?
Not exactly.
Okay. So the function is this.
So multiply this.
If this is 5, this is 5, this is 5. If this is 10, this is 10, this is 10. But what if this is f of x plus h? What if this box is x plus h? What do I have here?
Let me get that right. Well, let me write something.
Okay, very good. Better? How are we doing?
Yeah, Professor.
Yes, I'll be right there. Okay, I see what you're doing. So you're multiplying here. Okay. But the denominator, how did we get the denominator? Oh, you're just showing that you're multiplying. Okay, okay. If that works, that's fine. Yes.
So you would combine these two and then multiply.
Yes, but first I would have to write a long fraction line at the top, and I write the least common denominator, and then yes. That's exactly what I would do. But I would go one step ahead. But you're on the right track. Yes.
Would so that
Yes.
okay, simplify.
Yes. You can simplify. You have to find the least common denominator.
Right.
Yes.
So what is the least common denominator?
They have nothing in common, so it has to be the product. So imagine 1/2.
Them together.
1/2 plus 1/3. 6.
Yeah.
Because they have nothing in common. How are we doing? Very good. Minus. How are we doing? Because something happened. So you have a negative 6h and you put that was good. Okay, how are we doing? Okay, some of my students practice, some of my students think they know and they don't practice. But they will, right? Okay, so let's do this together. Ready? So here it is. The numerator is 2x plus 2h plus 1 over x plus h minus 3. And then 2x plus 1 over x minus 3. And then over h. Agreed so far? Everyone, do we all have this?
Yes.
Yes? Okay. Then I have to find the LCD, which is x minus 3 times x plus h minus 3 divided by h. Now, I want you to be careful with something. You have a lot of parentheses in there. If you can keep track of them, it's fine. But they're not really necessary. Okay? But again, if you're fine with them, then don't change anything. Okay? So I saw parentheses here, so be careful with those. Which is, I don't disagree. I'm just saying be very careful. So obviously this needs an x minus 3, and this must need the other one, which is x plus h minus 3. Agreed?
Yes.
And of course I ran out of room, so I have to rewrite. So the least common denominator is x minus 3, x plus h minus 3. This is me, but you don't have to make a change. But I always recommend distribute from the binomial, not from the trinomial. So x times 2x, 2x squared, plus 2xh, and plus h, plus x. And then minus 6x, minus 6h, and minus 3. And I'm done with this product. Again, it's not a mistake, but be careful with those parentheses. And then I have 2x distributed here, but I have to change the sign. So this is negative 2x squared minus 2xh plus 6x. And then I have minus x, minus h, and plus 3. And this is the first time I managed to fit everything in one row. Yep, it rarely happens. So now I think, oh, okay, so I'm calculating the difference quotient. Two things have to happen. Everything that does not have h. Potentially other terms too, that's even better. But at least terms without h must go away. 2x squared with negative. 2xh happens to go away. The negative 6x with the positive 6x, the positive x with the negative x, the negative 3 with the positive 3. So what is left is this term and this term. I combine them, I get negative 7h divided by x minus 3, x plus h minus 3, and I flip in the 1 over h. I simplify. This is the second thing that must happen, and the simplified form is the negative 7 over x minus 3, x plus h minus 3. Try to get into a habit. It's not a bad habit. It's not mandatory. It's not required. But try to get into the habit of putting the smaller factor in front of the bigger factor. It doesn't matter really. Okay, next question. Any questions on this? Yes, please.
What did you do at the end to get rid of the h with the 7?
H divided by h is 1. H divided by h is 1. So the numerator was negative 7h. The denominator was this. The fraction at the bottom is h over 1. I have to flip it because I multiply. I change this into a product, so 1 over h. Is this okay, everyone? Okay. So I would like us to look at these conditions, write them down, and create a function, a graph of a function. There is more than one correct answer. Sketch a graph of a function that satisfies these conditions. So let me read them to you. Limit of f of x as x approaches 0 from the left. Limit of f of x as x approaches 0 from the left is 2. The limit of f of x as x approaches 0 from the right is 0. So from the left of 0 is 2. From the right of 0 is 0. Limit of f of x as x approaches 4 from the left is 3. Bless you too, thank you. Limit of f of x as x approaches 4 from the right is 0. F of 0 is 2, and f of 4 is 1. A graph, please, quickly. This should take 1 minute. So if you get something like this on the quiz next Monday, you will have no difficulties, right? With the difference quotient, piecewise defined function, and so on and so forth. Remember, one of the best ideas is to summarize the information in a table. Not just immediately start plotting some points and so on and so forth. That's the easiest way. Okay, that's perfect. Yes, that's fine. That's fine. I would have summarized the information because in the next chapter it's going to be way more difficult. There will be a lot of signs in there for the first and the second derivatives. So if you're not trying to get used to using the table now, it's going to look foreign. The next examples, in the next chapters. Always summarize the information before you go ahead and do anything. You want me to read anything? If you finish with that, please determine these two limits. So if you finish the graph, so let's determine those two limits. How are we doing? Very nice. That's the best way, because I'm going to add things to that chart. Good idea. Yes. Since there is a different value for this, you will not make those two parentheses touch. The same thing here, because there is a different value in the middle. How are we going? Yes, perfect. Oh, okay. Just repeat it. Yes.
Right.
Okay. Okay. Can you come in early next? Yeah, you can please. Okay. How are we doing? How are we doing? Okay, we had an example last time. Good. We had an example last time. We have to only fulfill the conditions that are given. The rest you can do whatever you want. So we'll talk about it right now. Okay, ready? So let's do this together. I highly recommend the following table like we did last time. So remember, that's the reason why I post the notes and I post the videos. So you can redo those problems we did in class several times. This is the first layer. The second layer is look at the examples solved in the book for each section. The third layer is this. Okay? So far. And only then you can say, I'm comfortable, I got the skill, throw at me anything, I will be able to present the solution correctly. So first of all, I'm looking at this and I only see 0 and 4. I don't see anything else. So the action is around 0 and 4. I don't care for any other number. I would not put in the chart any other number but 0 and 4. So 0 and 4. Then I see that f of 0 is 2. I see that f of 4 is 1. So I'm done with these two. And now I'm trying to see what happens left and right. To the left of 0 is 2. To the right of 0 is 0. To the left of 4 is 3. To the right of 4 is 0. Yes, if you want, I can change this. Now I can because these two numbers are the same. And I can write this. It's not a big deal. I don't have to. I already know what to expect, right? So now when I'm asked to find, just make sure, then check, and so on and so forth, it's very clear. From the left of 0, the limit is 2. The function value is 2. From the right of 0, the limit is 0. From the left of 4, the limit is 3. From the right of 4, the limit is 0. And the point is 4, 1. And now again, we're not going to have the same type of function, I'm sure. So here's my function. Oops, that's 3. So at 0, the function is 2. On the left-hand side, the limit is 2. Okay, I'm going to do this. On the right-hand side is 0. I'm going to do this. At 1, 2, 3, 4. At 4 is 1. This is a full point. At 4 is 1. On the left-hand side is 3. So 1, 2, 3. And I'm going to do this. That's what I want. It will not. Just make sure that it doesn't. And then I have this point, which is an open point, and I do this. I didn't have to. I just wanted to show you that we can come up with anything you want. Okay. Any questions? Any questions?
So the line you came up with.
The graph.
The graph, yeah, like.
0, 2.
Yeah.
The limit from the left is 2.
Yeah.
The limit from the right is 0. 4, 1. The limit from the left is 3. The limit from the right is 0. We're not told anything else, which means I can do whatever I please.
So that line was just arbitrary.
You mean here?
Yes.
This is my graph.
Yeah, what you want.
You can change this into a vertical asymptote. I can change the whole thing right here in the middle and say, is this? I would put a vertical asymptote because I'm not told not to. And then I have the other side like this. in the middle. I can do whatever I want, as long as these conditions are fulfilled. Is that okay? Good. So let's take a look at these two limits. So we have the limit of 5 minus x over x minus 3 as x approaches 3 from the left. And then limit as x approaches 3, 3, times sine x minus 3 over 7x minus 21. Okay. So I will not be able to spend half an hour on types of problems like these unless you have questions. Then there is no question. I have to answer your questions. So I'm hoping that moving forward, we know what to do. Number one, we redo the problems we did in class. Number two, we look at the examples solved in the text. And number three, we do at least half of these problems every day. If you say, I'm not going to work on math today and tomorrow I'm busy, by the time you get to it, it may be late.
So would you say it's more beneficial to do those or the online assignments?
I would say that I would definitely read the book and do the examples that are similar to the ones we did in class. If it's something very different, then you have to show it to me. Because as you see, they're selected. So I'm trying to stick with this, because otherwise we're not going to be able to finish everything. So I recommend these problems because they're odd number problems and you can check the answer in the back. Once you're done with this, when you get to your homework to practice, it will not take long.
Okay.
Because you already have the 3 layers.
So doing both
Problems, yes. And from there, you can do whatever you want. You don't have to do all of them.
Yeah.
So there are 20 problems, do 5 if you're doing both.
Okay.
Because this gives you the chance to check the answer in the back. So this will always be good practice before you start homework. Okay. So do we have an answer for the first limit? Do we all agree with negative infinity or have to show? It's okay if you say show. Okay, very good. So remember, every time I'm asked to calculate the limit, although it's a contradiction, I still have to plug it in. Okay? I keep it quiet. I don't tell anybody but you. And so when I plug in 3, I get 2 divided by 0. I know immediately that this is not an indeterminate case. It's an undefined case, so the limit cannot exist. When the limit does not exist, I have 3 options. Positive, negative, infinity, or does not exist. Now, knowing that the answer would be an infinity because it's a rational function, now I plug in 3 from the left, 2.9. 5 minus 2.9 is still a positive number, but 2.9 minus 3 will be a negative number. So what is the answer? Positive over negative is negative infinity. I will immediately conclude that x equals 3 is very good, very good. It's a vertical asymptote for this function, yes. Now what do I do here? Do we have an answer? Awesome. So let's do it together. So first I have to plug it in. When I plug in 3 minus 3 is 0. Sine 0 is, that's cosine 0. Sine is measured on the y-axis. So y is measured on the y-axis. So at 0, the y-coordinate is 0. So, okay, let me refresh your memory on this just for 1 second because this is important. Okay. This is the unit circle. Bear with me. It's not 100% circle. I'm sorry. So this point here has coordinates 1, 0. Do you agree?
Yes.
This one has 0, 1. Do you agree?
Yes.
This one has negative 1, 0. And this one has 0, negative 1. Now I'm going to picture a little center angle, like standard. meaning this is the initial side and this is the terminal side. I will form a right triangle, and for this angle alpha, this piece is sine alpha. So it's on the y-axis. So these two, this is always sine. This is always sine. This is always sine. And this is always sine because it's on the y-axis. This piece is cosine alpha. But since it's on the x-axis, this will be cosine, this will be cosine, this will be cosine, and this will be cosine. So for any point on the unit circle, the first coordinate is always cosine. The second coordinate is always sine. So if I ask you now, how much is cosine of 270 degrees? 0. Cosine at 270 degrees is 0. If I ask you what is sine of 180 degrees?
0.
Yes, because it's the y-coordinate. So coming back here, how much is sine 0? Is the y-coordinate at 0? 0. So that's why 3 times 0 is 0. And when x is approaching 3, the denominator approaches. So there is hope for this situation because it's an indeterminate case, not an undefined case. However, I cannot factor and simplify. All I can do is think in terms of and change this x approaches 3 into awesome, x minus 3 approaches 0. I already have this that I needed in here. I have it in here. I have the 0. These 3 are fulfilled. But now the question is, can I get an x minus 3 here? Because if I can, then I cannot refer back to that limit by factoring out a 7. So then this piece, and this piece are all the same. And furthermore, I have the 0. So then the limit of all this, sine x minus 3 over x minus 3, when x minus 3 approaches 0, this will be what? 1. But I also have a 3, and I also have a 7. So 3 over 7 multiplied by 1 will be 3 over 7. Very good. Okay, so let's, any questions for me? Any questions?
Can you do that? I missed out that.
So this piece, and this piece are all the same, and this is 0. So the limit of sine of alpha over alpha when alpha approaches 0 is 1. But I have a 3 at the top, and I have a 7 at the bottom. So 3 over 7 times 1 is 3 over 7. Is this okay?
So what happens to the x minus 21?
We change it into 7 times x minus 3. Otherwise, the whole thing would not work. I have to have all these 3 pieces identical, and the piece x minus 3 approaches 0. Is this better? Yes, everyone? Okay. So now let's go back to our handout, which is this. So we are going to look at 2.3. We have to continue. I have not shown you anything yet from 2.3. We're going to pick examples right now. Let me see how I'm with the time here. Okay, I'm still fine. So what I would like you to do, depending on how much we can make progress today, I would like you to work on this limit, on this limit, on this limit, on this limit, number 10, and number 12. Not now. Yes, let's go back. I'm going to post this for you. Number 1, number 3, number 5, number 6. So 1, 3, 5, 6. And 10 and 12. Not now, but for Monday. So this is for Monday. Okay, So we're trying to finish to the 3 and then hopefully move on. Let's see. We are on page 107. And before we look at something very important, I would like you to choose any problem you want from 11 through 32, not the problems that I chose on the checklist. So by now, you should be finished with page 1, page 2, page 3, page 4, page 5. Okay. I will have to discuss page 6 with you because we haven't finished. But I don't want you to choose 12 and 20 on page 107. I want you to choose anything else you want from 11 through 32.
22.
Let's pick 2 problems. So we want to pick 22. Okay. What else? I'm going to pick 26. Okay. Very good. Okay. Perfect. So you said 22. So we have limit as u approaches 2 from the square root of 4u plus 1 minus 3 divided by u minus 2. We're asked to determine this limit. What is the first thing I have to determine or do? Say it again. I have to plug it in. Yes, I have to. Yes, of course. Yes. Good. So if I say something silly, I'm just trying to like hope or not. It's a little bit silly. It's not mathematical. This is not how, but I'm hoping that this will you know, trigger your memory. So I plug it in. 4 times 2 plus 1 square root of 9, 3 minus 3, and the denominator. Good. One discussion here before we talk about how we proceed. What is the first step? Let's say I have a polynomial. And I ask you to plug in 5. So I have p of x, a polynomial, any degree you want. And I ask you to plug in 5. And I just remember what Joey told me, and that was the question, about the synthetic division and the remainder theorem.
Oh, yeah.
And yes, that's exactly what it was. Good. Just clear. Good. So if I have a polynomial and I ask you to plug in 5, so you determine p of 5, correct? Now let's suppose you get 0. What does that mean? So I plugged in 5 in a polynomial, and I got 0 as an answer. What does that say about the polynomial? Anyone but Joey? For a second. You're not banned or anything. No? 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 So let's say you ask me to divide 27 by 3. Okay, 27 divided by 3 is 9. So the remainder is? So what does 3 represent for 27 if the remainder is 0? Awesome. Perfect. Stay with me. I plugged in 2 in a polynomial, and I get 0. What does that mean? What does that say about the polynomial? Which is the factor of the polynomial? No. No. U minus 2 is a factor. If I ask you to plug in negative 3 and you get 0, what is the factor that the polynomial has? It has to be a polynomial, not a number.
U minus 3, or U plus
Plus 3, exactly. So one more time. I have to write this down for you. This is the remainder theorem and the factor theorem. So if I plug in 2 in a polynomial and I get 0, x minus 2 is a factor of that polynomial. In the polynomial, I plug in negative 5 and I get 0. What is the factor then? You see how important this is. So please commit this to memory. When I plug in a number in a polynomial and I get 0, x minus that number is a factor of the polynomial. So what do you think will happen here? if the limit exists, what will be the factor from the top and the same factor from the bottom that must go away to make the limit exist, if it happens? Minus 2. So this is what I'm after. Somehow eliminating, crossing the u minus 2 from the top and the u minus 2 from the bottom. Not so fast, we're not there yet. So now I look at the function and I see a square root right there. So then what would be the only thing that I can do to this function?
Square.
No, you have to conjugate from.
So I have $10 in my pocket and I'm going to square that.
Sounds good.
Yes.
But the dollar square does not exist. There is no measurement unit for that. No, what I can do to any number is multiply by 1. That is allowed. I have $10 in my pocket and you say multiply by 1. Okay, that's fine. Nothing changes. So I have to multiply by 1, but a different type of 1. What type of 1? And I told exactly. I need to multiply by 1, but that 1 has to be a specific type of 1. Obviously, it has to be the same top and bottom, has to be the same because it's 1, and I can do that. So then what do I get? What do I have to multiply and divide by? Right, the square root of 4u plus 1. Exactly, and it has to be the same. If it's not the same, it's not 1. Right? So you know what you have to do for number 6. If it is 0 over 0. Maybe it's 5/3, and then you're done. And I'm going to address that in a minute. Okay, very good. So then one other very important item. You cannot drop the limit operator till the very last step. So if you don't start with a limit operator here, that's wrong. Okay? So I have to write the limit as u approaches 2. And now the denominators are clear. I mean, the factors and the denominators are clear. I cannot do anything to that. But now please give me the top. And that's the reason why I started with refreshing your memory on 3 special products. So this is a minus b times a plus b. How do I multiply a minus b times a plus b? What do I get? X squared minus a squared minus. Good. So give me a squared. And give me minus. Very good. What do you hope now? What do you expect now to happen before you even look at the top? A factor of we just discussed exactly. A factor of u minus 2 has to come out from the top. If this limit exists, there must be a u minus 2 that will cancel the u minus 2 from the bottom. Otherwise, the limit will not exist. So, limit, do not forget the limit operator. We're not done with it yet. What do we have at the top? What do we have at the top? Yes, what do you factor out? Good, please give me what you have in parentheses. Aha, so we are on the right track. You wanted to say something? I'm sorry.
What's the limit operator? That's right.
This is the limit operator.
Okay,
This is the limit operator. So what you would recommend? Yes, u minus 2 divided by u minus 2 is 1. U minus 2 divided by u minus 2 is 1. And now the limit from the top is the limit from the bottom as u approaches 2. 4 times 2 is plus 1. The square root of 9. 3 plus 3.
6.
lot of steps, a lot of work. And now I would like to clarify two things here.
Can you plug in 2 at the end there?
Yes, because the problem has disappeared. What was the problem? U minus 2 was the problem. That was the only problem here.
Keep implementing that section.
4 times 2 is 8, 8 plus 1 is 9, the square root of 9 is 3, 3 plus 3 is 6.
So why do you put 2 back?
Because u approaches 2.
Okay.
As u gets closer and closer to 2, 4u gets closer and closer to 8. And then 4u plus 1 gets closer and closer to 9. And the square root of 9 is 3, 3 plus 3 is 6. Is that clear? So what do we conclude right now? That if I want to determine the limit of a polynomial as x approaches a, what do I really do? Exactly. So if this is a polynomial, and I want to determine the limit of a polynomial as x approaches whatever number, then all I have to do is plug it in. And you will say, this is a contradiction, you just told me not to plug it in. True, but it's the same thing. Eventually I will get the same answer. Now here's another question for you. So this is for a polynomial. What if I have a limit of a polynomial divided by another polynomial as x approaches a? There are basically 3 options here. One of them is 0 over 0. The other option is, for example, any number, not 0, over 0. And the third option is a number divided by another number. That's pretty much all that can happen when I determine the limit of a ratio, of a rational function. I can get 0 over 0, which is not bad. It could be end up to being bad, but initially it's not bad. I can have this, which I know it's bad. This does not exist, or it's plus or minus infinity because it's an undefined case. And this is awesome. The numerator goes to 1, the denominator goes to 5, and I'm done. So let me give you examples from each. So for example, I have limit as x approaches 1 from x minus 1 over x minus 1 times x plus 2. This is one example. We'll come back to it in a minute, right now. Here's another example. Limit as x approaches 1 from 1 over x minus 1. So I'm going to say x from 1 from the right. And here's another example. Limit as x approaches 1 from x plus 1 over x plus minus 3. X plus 3 doesn't matter. Let's start with the easiest. Which one is the easiest from these three, among these three? Of course. So if you plug in 1 here, because that's how we determine the limit of a polynomial, you have 1 plus 1, which is 2, and you have 1 plus 3, which is 4. So it's 2 over 4, or 1/2, and I'm done. The second easiest is the second one. When I plug in 1, I have 1 over 0. So I know there are 3 options. Infinity, negative, infinity, d and e. Okay? But I have to plug in 1 from the right. 1.1. The top is positive, the bottom is positive, so the limit is? Very good. As expected, a number over 0, no hope. Now the first one.
I'm sorry, when would it be d and e in that case?
Not for the rational function.
Okay.
For other functions, yes. But for rational functions, it will not be. Okay, so then what about the first one? I have 0 over 0. I like that, right? But what will I do immediately? I know what the problem is. What is the problem? X minus 1 is the problem. As long as I eliminate from the top and eliminate from the bottom, and hopefully there is no other, because I could have, if I put this squared, the limit will not exist. Even if I remove 1x minus 1 from the top and 1 from the bottom, it will still not exist. But I have the same power. I eliminate the problem, and then I plug in 1 and I get 1 over 3. So what is the conclusion that we have to write? We know that whenever we determine the limit of a polynomial, plug it in, there's no headache, no problem, done. But how do I determine the limit from a ratio?
Take the limit of the top and divide it by the limit of the bottom.
Only if both of them exist and the limit from the bottom is not 0. That's the condition for the limit law, right? No, the answer is this. If the number a is in the domain of the function, plug it in and you're done. 1 is in the domain of the function. Next. But if 1 is not in the domain of the function, like here or like here, I have to be careful. So that's the answer. So the limit of a ratio, the limit of a ratio plug in if A is in the domain. 2, careful, otherwise. Very careful otherwise. Why? Because you may encounter one of these two. If the number A is in the domain, no problem. Just plug it in and you're done. No other action is required. But if it's not in the domain, then you have to be careful. Okay, you also suggested 26. So let's look at 26. And then I would like to talk about a theorem here. And that will be the end of this section, but I still would like to show you one more example, at least one more. Okay, so you pick 26. So we have limit as t approaches 0 from 1 over t minus 1 over t squared plus t. I'm given a limit. What do I do? I'm asked to find this limit. What is my first thought? That's awesome. Awesome. It was a little bit of a trap because I was expecting you to say plug it in, but you can't. Right? It's 1 over 0. That's number 1. Number 2, I was hoping that you would say, oh, the limit law says that the limit of a function f minus a function g is the limit of f minus the limit of g. But you can't. Why? Because the limit of f is not a number. And the limit of g is not a number. So these would have been 2 dead-end paths, right? You cannot separate because the limit of the first is not a number and the limit of the second is not a number. And that's what is required by limit laws. Second thing that was a trap was plug it in. I can't. I shouldn't say I can't. I would say not yet. So yes, absolutely I have to find the least common denominator.
So let me ask you this. I didn't even think about those two things. My first thought was to do the least common.
Right.
And
it makes sense because you want to simplify the function first. It makes perfect sense.
would it be okay if I just do that every time? Like instead of skipping over?
I can't give a recipe without seeing the
Gotcha.
problem. I'm so sorry. I don't want to say something. So now limit is I just wanted to make sure here, one more thing I don't want to forget. Notice we dropped the limit operator right at the very last step when we replaced u by 2. Not before. The limit operator has to stay with us till the final stage in which we replace u by 2. Is that clear? Okay, perfect. Good. So then in this case, I cannot plug it in and I cannot use a limit law. We agree? Okay, perfect. I would recommend first factor t here. That should be the first step. So 1 over t minus 1 over t times t plus 1. Now I will determine the least common denominator.